Hello guys, I hope you all are doing good. I am Vaishali Kikan and we are discussing the electronics engineering. Today in this video, we are going to see the introduction to the semiconductor diodes. What are semiconductor diodes? Why do we require them? What is the basic structure of the semiconductor diode? All of these things we are going to see in this video itself. So this video is going to be really interesting one and informative one, and I hope all of you are watching this video with your utmost attention. So let's start our discussion with the introduction to the semiconductor diode. So before starting the introduction, we are going to see the various applications. We should understand the wide applications of the semiconductor diode so as to understand the semiconductor diode in detail. First of all, we will be seeing its importance. If something is having very wide applications, it is a very useful thing and we need to understand it very clearly and with utmost attention. So you can see on the screen we have wide applications of the semiconductor diodes. So it is used for the rectification purposes. What is a rectification? With the help of rectification, I can convert the bidirectional alternating current to the unidirectional direct current. Right, so current which is there in the bidirectional alternating current is changing its value throughout the time. It is having the sinusoidal nature, whereas the direct current is having the constant value throughout the time. So I hope you understood that if I need to convert the bidirectional AC to the unidirectional DC, we can use the rectification, and for the rectification I can use rectifier, which is a diode. So diode can easily convert the alternating current to the direct current, and this is a very simple application. In the upcoming videos we are going to talk about all of these applications that we are going to discuss. So we will be talking about the rectifier also in some upcoming video. So it is going to convert the AC power, right? So AC power to the DC power. Why do we require to convert them? Because the power that is delivered to our home is AC power, and most of the electronic appliances are working on the DC power. So we need a transformer which converts the AC power into the DC power, right? So now here we will be using it in the radio, TV, computers. All of these electronic components are using the diodes which are converting the AC power into the DC power. Right, so even we have the transformers. Transformers can convert the high amount of power into the lower level, or low amount of power to the higher level, so that the electronic equipment will be easily working with them. Right, after that it is used for the radio frequency signal to convert into the audible signal. Like we have the radio. In the radio, what we are receiving? We are receiving a radio frequency signal and we need to convert it into the audible signal. So this also we can do with the help of the semiconductor diodes. Right, after that we can make the DC power supply with the help of the rectifier. I have already talked about the purpose of the rectifier. It is used to convert the AC into DC. So to convert the AC power into DC power, I can easily use the rectifiers. Then it is used for the demodulator as well as detectors. In the optical communication, it is used to detect the light signal. Right, it is used in the photo detectors which are detecting the light signal and it will be converting it into the electrical signal. It is used in the demodulators also. So demodulators are taking out the information from the modulated signal. So it is taking out the message signal from the carrier signal and message signal superimposition. So we have the superimposed signal which consists of carrier and message signal, and from this superimposition I need to extract out the message signal. Again the diodes can do that, right? So diode circuit will be required for the demodulation and the detector. Then it is used for the clamping network, right? So clamping means we can take this signal level to another level, right? If I need to increase its voltage level or the current level, I can do it with the help of clamping. We are going to talk about the clamping circuits as well in some upcoming videos. Then it is used for the clipping circuit for the waveform generation, right? It can be used for the clipping of the circuits as well. So it is used as a clipping of the signals as well. So we can clip the signal with the help of the clipping circuit, and we are also going to see about its detailed application. So these are all the things that we have in the next chapter. In this chapter, we are going to deal with the semiconductor basics only, right? So now after that, it is used in the switches in the digital logic circuit. We can make the switches, we can make the various gates also with the help of the semiconductor diodes in the digital logic circuits. So I hope you understood the wide applications. So I talked about the diode rectification. So you can see this is the AC signal in. So this is the input signal and now this is the DC output. So the diode, when it is used, so this is the input signal is supplied over here and the output signal that we have received is looking like this. And what we have used a simple diode, right? So when I am using a simple diode is going to remove this negative part of the signal. So it is going to send only the positive waveforms of the signal, and this is the application which is called the rectification. So we have removed the bidirectional signal into the form of the unidirectional signal. We have removed the negative part of the signal and the bidirectional signal will convert into the unidirectional signal. So I hope you understood the concept of diode rectification. Now, as we all know now the various applications of the diodes, now let's understand what is a diode, its structure. So this structure represents my PN junction diode. Here we will be having the anode and here we will be having the cathode. Right, so anode terminal and the cathode terminal are there. Now this is my p-type of silicon. I have already talked about the extrinsic semiconductor in the previous video. What is p-type of silicon? Which is doped with the group 3 elements like the boron. So here we will be having the doping with the help of group 3 elements. Here we have the n-type of silicon, which means I have doping with the help of group 5 elements, like we have the doping with arsenic or phosphorus, right? So now if I take p-type of silicon and if I take n-type of silicon, so these two metals, if I combine them end to end, right, so it will be making a simple structure which is called the PN junction diode, right? So this structure is called as PN junction diode, and the symbol of the PN junction diode is like this. So this is the P terminal and this is the N terminal, right? So the bigger part of the triangle where we have one side of the triangle, this is representing the P terminal, and where the two sides are meeting, the V structure, it is the N terminal, right? So here we will be having anode and here we will be having cathode. So now what is the PN junction? The junction that is formed at the layer where these two elements, these two materials are joining. So at this point I will be having the junction. So the junction width is around 10 raised to power minus 4 centimeter, right? So this layer in the vicinity of this interface of P or N type of silicon is the PN junction, right? So PN junction is the interface between the P type and N type semiconductor, right? So it is going to form the semiconductor diode, right? With the help of PN junction only, it is a very crucial part of the diode, so which is going to form the semiconductor diode, and this is the reason semiconductor diode is also called the PN junction diode. It is also known as the crystal diode, right? So I hope you understood the basic structure of the PN junction diode. Now coming to the depletion layer. What is the depletion layer? First of all, we are going to see the formation of the depletion layer. So here you can see we have this type of material and this type of material. Both of them are different to each other. Now here you can see we have more of electrons. So the dot is representing the electrons. So obviously this is N type of material, right? This is the N type of semiconductor which is represented by green. The red is representing the P type of semiconductor. Now why it is representing the P type of semiconductor? We have excess of holes over here, right? You can see we have various holes over here. Now here we have the plus type of ions which is called the donor ions, right? So here we will be having the donor ions and here we will be having the acceptor ions. Acceptor ions can accept the electrons, right? And here the donor ions, because it has donated the electrons, so here it is known as the donor ions, right? So now here at the depletion region, what will happen? So at the interface, at the PN junction, PN junction was the interface, and I told you in the near region we will be having some changes. So at the depletion region, what changes I will be having? So depletion region is the near area of the PN junction at the interface. At some level I will be having the depletion region. So from the interface somewhat towards the left side and somewhat towards the right side, we will be having the depletion layer, right? So what will happen? So here you can see we will be having, initially we will be having excess number of electrons because it was the N type of semiconductor. Here we will be having excess number of holes because it was the P type of semiconductor. Now we all know electrons has the affinity to attract the holes, or holes can attract the electrons. These electrons can move here and they can combine with the holes, so that here we will be just left out with the ions. Here we are left out with the acceptor ions, and here we are left out with the donor ions, right? So the layer which is forming only the acceptor and the donor ions, here we will not be having the charge neutrality. At this N-type region and the P-type region, we will be having definitely the charge neutrality, and we will not be having any electric field. But now you can see we have the layer of charges present here. At both sides of the depletion region we have some ions. So now when I know the positive and negative ions, when they are separated by some distance, it is going to create some force on each other, and here we will be having some electric field also developed. So this electric field that is developed from positive to the negative charge is the intrinsic electric field. Right, I am representing it with EINS. So the depletion region is the layer which contains only the ions, which are immobile ions. Now the electrons and holes can move, but these ions are immobile ions, and because they are present at the specific location, they are going to provide some electric field which is called the intrinsic electric field. Right, so acceptor ions are going to accept the electrons, donor ions are going to donate the electrons. So these are the positive ions and these are the negative ions. So initially at the left side we will be having N type of carriers, right? We will be having majority of electrons, and at the right side, at the P side, we will be having the majority of holes, and at the depletion region also we will be having excess of electrons and excess of holes, which will combine at the depletion layer width. Right, so at the depletion region, after some time we will be left out with the immobile ions only, which is going to generate the intrinsic electric field. So the layer which contains only the immobile ions is the depletion layer. Right, so electrons from the N region will diffuse into the P region, and electron reaches the P region and combine with the holes, and region near the PN interface lose neutrality and becomes charged, as I have already told you. And this is how we will be forming the space which is going to called as the charged region, which is known as the depletion layer. So after this time you must understand the concept of the depletion layer, and the depletion region is a very important concept which is going to provide the functioning to the diode. Right, so diode will be functioning very properly if I have a properly formed depletion region. So I hope you understood each and everything that I have discussed in this video. If you have any doubt, you can put the doubt in the comment, and I will be trying to resolve your doubt as soon as possible. I hope you like this session. If you like it, please push the like button, subscribe to the channel, share it with your friends, and also give me your feedback. Thank you so much.